Once again, I'll ask that you will have made sure to fill out that sheet on tangent and cotangent with the values before watching this. And we'll go through it the same way, how to graph tangent and how to graph cotangent. So notice if we talk about when tangent is defined, as you look at your table of values, you should see tangent is undefined every pi over 2. So the way I can write that is I can say tangent is undefined if we have pi over 2 plus pi over 2n. So anytime we add, and that is really hard to read, my 2's, I apologize. Let me see if I can write that a little bit better. A little more legible. Pi over 2 plus pi over 2n. That looks better. So every time we add pi over 2 to pi over 2 to pi over 2, we're going to find that we continue to hit undefined marks. Since tangent is equal to sine over cosine, we can also say it's undefined when cosine equals 0. So either of those are two great ways to state when tangent is undefined. When we start looking at the graph, once again, we're going to see each of those places where it's undefined. There's a vertical asymptote. So all I'm going to do is I'm going to go to my table that I've already filled in, and I'm just going to draw in undefined vertical asymptotes with dashed lines for all my undefined places. And doing that, I get the graph will start to look like this. And then once again, I just need to figure out what can I fill in. And then again, I'm going to just fill in between each of my asymptotes. And my tangent function is going to look something like this. It almost looks like a bunch of cubic functions. And of course, this would continue to repeat itself if I were to draw more of it. Just talking then quick about the domain and range of tangent, notice that my domain is all x values except x cannot equal, again, this idea of anywhere where there's an asymptote or undefined, so that pi over 2 plus pi over 2n. And my range is going to be all real numbers. So a little bit different than sine and cosine, because as we've looked at sine and cosine, we've seen that their domains are going to be all real numbers, whereas their ranges are going to be oscillating between that -1 and 1. So very different look to it. Cotangent looks very similar to tangent, except for it's almost like it's reflected. It's not reflected, but it's going to have that look to it. Again, I'm just going to go ahead and create that drawing based on my table from that worksheet. So I'm going to go ahead and plot where it's undefined, and I notice that cotangent is undefined every pi n, or where sine is equal to 0, since this is cosine over sine. So again, just going from my table, at -pi over 2, I am at 0, and at 0 I am undefined. And cotangent will start up here, and then we're going to, oh, I missed my dot. I should have crossed through my point. And here's going to be my cotangent function. And so once again, domain has a little bit of restrictions. It's all x values, except x cannot equal, again, this idea of every time we have that vertical asymptote, which is occurring every pi n, and again, my domain is all real numbers. In the next video you'll watch, you'll see how we can apply phase shifts and amplitudes and periods and things like that to the cotangent and tangent functions.